All right, welcome to the first lesson in the circles unit. Today's going to be pretty simple. I'm just going to discuss the parts of a circle and the circumference formula. Please make sure that as you're watching this video, you're answering the questions that are provided in Edpuzzle. You will receive a grade for answering those questions so that I know that you are watching this video. All right, so here we go. The first question says, the first part discusses the parts of a circle. So, one of the most important parts of a circle is the center. This right here is the center. Now, a circle is named by its center. So whatever letter is there is the name of the circle. This is the center. It is just a point in the center of a circle. This next part right here is pointing to this little dashed line right here with those little squares. That is going from the center to a point on the circle. So the distance from the center to a point on the circle is called a radius. Now we have another dashed line. This dashed line right here. Notice this line goes through the center. It does not stop at the center. That is called a diameter. A diameter goes from one point on the circle through the center to another point on the circle. Now there is a relationship between the radius and the diameter. The diameter is 2 times the radius. Therefore, the radius is half of the diameter. So if you know the radius, you would times it by 2 for the diameter. If you know the diameter, you would cut it in half for the radius. And then last but not least, there's one more segment right here. Notice that this segment does start on a circle and ends up also on the circle, but it doesn't go through the center. This is called a chord. These are the parts of a circle. You will have to know them for the quiz at the end of the week, so make sure you know these for now. Now, the next is the circumference formula. There are 2 of them. One of them says the circumference is pi times the diameter. The other one says circumference is 2 pi r. They are actually exactly the same because 2 times r will give you d. In this first one, this entire segment right here is the diameter. So the diameter is 3, which means the circumference would be pi times 3. Now we normally don't write the 3 in the back, so we would write it as 3 pi. In the second circle, the 3 represents the distance from the center to a point on the circle, so that is not the diameter. That is the radius. So in this circle, the circumference is 2 pi times the radius, which is 3. Then you would multiply the 2 times the 3, and you get the circumference is equal to 6 pi. These are both the exact circumferences because they both contain the pi symbol. They are not rounded answers. They are exact answers. Okay, so here we have a circle with lots of segments in it. And on the right-hand side, we're going to answer all the questions. The first one says to name the circle. A circle is named by its center. So if the center is point A, we are going to call this circle. You put a dot inside of it, A. Name the radii. There's a lot of radii in this picture. They all start at the center and have to hit a point on the circle. So there's one. That would be radius AD. Segment on top. Here's another. AC. Another. AF. AE. Again, all radii must start at the center and hit a point on the circle. So last but not least, we have AB. Name the diameter. There are a few diameters in this circle. The definition of a diameter is that it needs to start on the circle, pass through the center, and hit another point on the circle. So there's one of them. That is diameter BE. Whoops. There's another one here. Starts on the circle at C, goes through the center at A, and ends up back on the circle at F. So that would be diameter CF. Name the chords. The chords have to have endpoints on the circle. So actually a diameter is a really special chord. I'm going to erase all of this so that we can see all the chords as I do them. So a chord has to start on the circle and hit another point on the circle. So here's just a generic chord. Starts at G on the circle, ends at C. Now, all diameters are also chords, but not every chord has to be a diameter, because by definition, you have to start on the circle and end on the circle. You don't have to pass through the center. It's just special that this one does. So FC, a diameter, is also a chord. And then, of course, we have the other diameter BE, which is also a chord. Remember, every diameter is a chord, but not every chord is a diameter. Okay, next part, if BE is 16, I'm going to erase this, BE. BE is the diameter of the circle. So if the diameter is 16, it says to find AE. So if the diameter is 16, the radius is going to be half of that diameter, so the radius is going to be 8, which means from A to E is 8. Now, BE is still 16. It says to find AD. AD in this picture is also a radius, which means it is also going to be 8. I'm going to write something down here at the bottom, and it's extremely important. All radii of the same circle are congruent, which means if the radius of this circle is 8, all the radii are going to be 8. So let's look at the next part. The next part says find AD. CF. The next part says to find CF. So we start at C and we go to F. Well, CF is a diameter. Well, if all the radii are 8, that means C to A is 8 and A to F is 8, which means the diameter is going to be 16. But if the diameter originally was 16, it will always be 16. So CF is also 16. Okay, and then the last question, let me erase this one. Says, does GC equal CF? So GC is a chord. It's a chord because it starts on the circle and ends on the circle. And CF is also a chord, but it's a special chord. It's a diameter. So now the diameter is always going to be the longest part inside of a circle. All the chords are not diameters. So the answer to this is no. The diameter, which is CF, is going to be greater than GC. Okay, so this is the last part where we're just going to practice what we learned and also work backwards, which some of the Delta math questions are going to do. This says to find the exact circumference. So to remind us, the circumference formula is pi times the diameter, or 2 times the radius. But in this case, they give us the diameter. So if the diameter is 6, the circumference is going to be pi times 6, which we write as 6 pi. The next one we are given the radius. So if we're given the radius, circumference is 2 pi times the radius. Now remember, 2 times the radius is going to give you the diameter. So if you want to do the diameter on its own over here, the diameter is going to be 2 times 5, which means the diameter is 10. You could then use the pi d formula and just immediately plug in the 10. If you memorize this formula, you can do 2 pi times 5, and then here is where you would multiply the 2 by the 5, and you would still get that same 10 with the pi. Now these ask us to work backwards. We're going to have to find the radius given the circumference. So underneath here, I'm going to write c equals pi d. Now, if c equals 100 pi, and if c is pi d, we know that 100 pi, let me just erase that, I missed a 0. 100 pi is equal to pi d. In order to get the radius, we first need the diameter. So to get the diameter, we're going to divide both sides by pi so that we get d alone, which means the diameter is 100. However, we need the radius. The radius is half of the diameter, which means the radius is 50. You could also write this as 100 divided by 2. That's the same as saying half of something, and it'll still give you that 50. Okay, the last one says to find the diameter given the circumference. So this one's going to be quick and easy because the formula, already has the d in it. So if c is 25 pi and c is pi d, 25 pi is equal to pi d. We're going to divide by pi again to get d alone, which means we get d equals 25 right away. And that's what the question was asking for. So we are done. Now, make sure you have answered all the questions along the way. And when you're done, go ahead and do the delta math with all the circumference questions.